Good morning, everyone. Today we are going to continue with chapter number 9, object oriented testing. These are the contents of object oriented testing, that is, object oriented strategies, test case design for object oriented software, then interclass test case design. From that, first we have seen that object oriented testing strategies. In today's session, we are going to see about test case design for object oriented software. So here test case is a suite of probable inputs and expected outputs that are tested on a particular component with the purpose of detecting failures. So here we are going to design a test case for particular component for detecting the failures, or if is there any bugs in that particular software. For that we have designed test cases. Based on the test cases, we are providing some inputs and we are expecting some outputs. So we are comparing that, uh, compare that output as according to that given input working. So your test case review for correctness. Test cases are review for the correctness. Yeah, these are some attributes for the test cases, like test cases having name of the test case, then location, that is full path name of that executable component, then the input data or commands, oracle, that is your expected test results against which the output of the test is compared. We are expecting some result based on the inputs, and we are going to compare that outputs with the given input here, or what output we are expecting, that expected result and the actual result, what we are getting and what we are expecting. We are going to compare that results. Then the logs, that output produced by the test, as per test case, what output we are getting. Then the report is, for the test case, is summary of the test result, summarize result of the test cases. These are the attributes of test cases, having name, location, input, oracle, log, and report. So yeah, there are some guidelines given by the Thomas and the Friedman for developing quality assured test cases. Like, we have to describe which features or function to be tested, then give the use case name, then we have to test the normal as well as abnormal use of the objects methods or object interaction and the messages sent among the objects. We have to test the boundary conditions, that is boundary value analysis. We have to test the boundary conditions. Then we have to assess the internal qualities of the software, such as reusability and extendability. So when any changes are made to the use cases, then the document them, so that we have to document that they can be used as the basis for the follow-up test if is there any changes in the test cases. So these are the attributes for the test cases, and some guidelines are there. So next part is test case design. Test case design stages. There are several stages of for the test case design. Like, identify the test resources. We have to identify the resources for the test environment. Then we have to identify the conditions to be tested. Like, we have completed with our software and we are ready for the execution and ready for the test. Then rank test conditions. We have to rank the test condition, which test case should be executed first. Then determine the correct result of processing. Create test cases. We have to design the test cases according to requirements and according to our inputs and what we are expecting. We have to validate all the fields. Then the document test conditions. We have to document that all the test cases in that report. Then template used for test cases. Templates, like here what we are going to use for the test cases here, like project name, test suite id and name, then version date, version number and version author, approval and distribution date, test preconditions, test case name, test case having number, ids, then type of testing, which type of testing we are going to use for testing, then objectives of the testing. These are the templates that are used for the test cases. Then now we are going to see about types of testing. So here there are two types of testing, that is black box testing and white box testing. Here, that black box testing. Black box testing is also called as behavioral testing or functional testing. So here black box testing involves only the functional testing of the component or for certain inputs that are certain input values, and it doesn't involve the code testing. Here in black box testing, it is also called as behavioral or the functional testing. It involves only the functional testing of the component for given input values, and it doesn't involve the code testing. In black box testing, we are not going to test the code. We are going to test the function input based on the. We are going to test only the function. Here you can see that we are having input test data, and here you can see this is black box. No view of the code or any other internal parts. This is the system. Here we are going to test only the functions, functional testing, and we are getting that output test data. Okay, so this is black box testing. Here it is clear that only the output according to the input are verified in the black box testing. Okay, only the output is verified based on the input. That means what we are suppose we are providing input as 2 plus 2, what we are expecting output as a 4. We are just taking that behavior of the or the functionality of the system, and here no assumptions made about the internal structure of the system. We are just testing the output based on the input. We are not testing the code here. This is the black box testing. And second one is white box testing. That here white box testing is also called as glass box testing or structural testing. Similarly, black box is also called as functional testing and behavioral testing. Now, that white box testing is called as glass box testing and or structural testing. We are providing the input test data as an input, and we are getting the output test data here. So here white box testing involves the complete knowledge of internal structure. In white box testing, we are going to test the internal parts or we are going to test the code. In black box testing, we are just testing that functionality of the system. But in white box testing, we are testing the code or internal parts that are available for the testing. Here, white box testing involves the complete knowledge of internal structure of the source code. It can be used to find the number of test cases required to guarantee a given level of test coverage. Here you can see that in white box testing, we are providing input test data, and we are testing the code or the internal parts for the internal parts that are available for the test, and we are getting the output based on that source code. We are in white box testing, we are testing the internal code. Here source code we are going to test. So here it is error based testing. White box testing is error based testing. So this kind of testing is searches the given class methods, and given it searches for the given classes methods for particular choice of interest, and it then describe how these choices to be tested. So it is error based testing. So white box test covers logical analysis of software elements and the possible paths of control flow. This is white box testing. Then next type of testing is usability testing. So this is one of the user acceptance test. This test works as a bridge between the user requirements and the developed system. Usability testing is one of the user acceptance testing, and it works as a bridge between the user requirements and the developed system. So it counts in the terms of effectiveness, efficiency, and satisfaction. So this test not only concern about after coding stage, it should begin in the early stages of software product development. So this test is needed to check if the user interface is easy to use or understand. So here usability testing is a non-functional testing technique that is a measure of how easily the system can be used by the end users. So it is difficult to evaluate the end measures, but it can be evaluated based on some parameters. There are some parameters. Based on that parameters, we are going to evaluate and measure that system. That is how easy to use that system for the end user. So here these parameters are like level of skill required to learn or use the software. That end user should be if that end user is technical person, then it will be easy for developer. Okay, but there are we are going to measure and we are going to evaluate that testing here, or we are going to evaluate the system here based on the level of skill required to learn or use the software. It should maintain the balance for both the novice and expert user. So the time required to get use to in using the software, time required for using the software, then the measure of increase in user productivity. If is there any productivity is in, for that measure of increase in that user productivity, if is any productivity is there, then we should measure that. Then assessment of a user's attitude towards the using the software, that user's attitude towards the system. So these are some parameters based on that we are going to evaluate and measure the system here. That is usability testing. It is also, or it is one of the user acceptance testing. That how that or that user interface is easy to use and understand for the end user here. So there are three types of usability tests, like scenario test, prototype test, and the product test. So here scenario test is one or more one or more users are presented with a specific scenario test. Here one, if the community of users are available, then the developers are quickly identifies that the user acceptance the system or not. That is scenario. That is, one or more users are presented with this specific scenario. One or more users are there. If that community of users or that group of users are available, then developer are quickly identifies that user acceptance for that system or not. That system is user friendly or not. Then next one is prototype test. So this test provides us a realistic working view of the system, realistic working of the system. Then product test. So this kind of test fruitful after only if the software product completes its design and its acceptance by the user. So this test is complete when the software product completes and its design is complete and it is accepted by the end user, or it is user friendly for that user. So these are the three types of usability test, that is scenario test, prototype test, and product test. Then next one is unit testing. Yeah, unit testing cannot be concerned with the whole system together. It focuses on the building blocks of the system one by one. We are going to test the system one by one, or unit wise, or the block wise. So it finds the faults in the subsystem. Here subsystem means the smaller units within the system. Here subsystem means the smallest units of that system. Here unit testing, it is a technique, or it is a testing technique using which individual modules are tested to determine if there are any issue by the developer himself. So it is concerned with the functional correctness of the standalone modules. So the main aim is to isolate each unit of the system to identify, to analyze, and fix the defects. So here we are going to test the module wise, test the system as a module wise, or we are going to test the system unit by unit, or we are going to divide the system unit wise and or in subsystems. So what is unit here? It is the smallest testable unit. Unit means it is smallest testable unit or small amount of code that we are going to divide that system into smaller amount of testable unit, that is encapsulated class. Okay. So here there are several types of unit tests are available. That is equivalence test, boundary test, path testing, class testing, state-based testing, and the inheritance and polymorphism testing. Here class testing, state-based testing, and inheritance and polymorphism testing is object-oriented testings are there. So here first one is equivalent test. So here it minimizes the number of use cases. Equivalence test makes class which has minimum two pieces of data. One is proper input and another is false input. We are having two pieces of data. One is proper input and another is false input. That means we are going to provide first one, in first case we are going to provide the correct input, and we will check for what after giving correct input what system will giving as output, and after providing the false input what system will give us. Okay. Then here for example, if the student want to take admission in BCS here, and eligibility criteria for percentage is minimum 50%. Then valid equivalence is percentage is that is greater than equal to 50 and invalid equivalence is less than 50. So these are the two cases. That means first we are going to provide the proper input for the testing, and second one is we are providing the false input. That is equivalent test. And second one is boundary test. So here boundary test is the part of equivalence test which concern with the boundary of the system. In boundary test we are going to concern about the boundary of the system. It is the part of that equivalent test. So here if we consider the example for that taking admission that we are having, if that student is having greater than equal to 50 percentage, that example, okay. So here of then the lower boundary is there as well as the upper boundary is there for that boundary test. In case of boundary test we are having the lower boundary and upper boundary. So yeah, that means in case of that admissions example, that valid percentage is 50 or 50.1 or 51. Okay, and invalid percentage is less than 50. That is like 49, 48. Okay, so here that upper boundary is up to 100% and the lower boundary is that at least 50%. Okay, that is boundary test. And third one is path testing. So it exercises all possible paths through the code at least once here. This is path testing. And fourth one is class testing. Here class is the smallest testing unit of the object oriented methodology. Here you can see that class testing for object oriented testing here. A class is the smallest testing unit of the object oriented system or object oriented methodology. So in class testing, each separate class with its instance is tested. Class testing, each separate class with its instance is tested. We are going to test each class and its objects. Then next one is state based testing. Here it tests and focuses the resulting state of the component with the expected state. That is state based testing. We are going to test the resulting state of the system. That is state based testing. And next one is inheritance and polymorphism testing. Here whenever we are applying the path testing technique to an operation that uses polymorphism, here all dynamic bindings are to be considered here. So here each subclass requires retesting because a method in a subclass and the same method in the parent class may be implemented differently. That is polymorphism. That's why we need to test that polymorphism and inheritance in the system. That is inheritance and polymorphism testing. That means whenever we are applying the path testing technique to any operation that uses polymorphism. Polymorphism means that methods we have to retest that method that is implemented in subclass or in parent class. Okay, we have to test both the methods here. That is, these are the types of unit tests. Then the advantages of unit testing. So here advantages of unit testing are it reduces defects in the newly developed features or reduces bugs when changing the existing functionality. It reduces defects in the newly developed features and it reduces the bugs because we are checking that system unit wise or that unit is small amount of code or it is a class. That's why it reduces the defects or it reduces the bugs. Where testing whole the code block wise or unit wise. So here it reduces the cost of testing as defects are captured in very early phase. Because suppose once we have designed one module and we are testing that module at that time, that's why in the early phases we are performing the testing, so it reduces the cost of testing as defects are captured at the end. We are having some like less defects in the system. That's why it reduces the cost of testing. So it improves the design and allows better refactoring of code. Unit tests when integrated with build gives the quality of the build as well. It gives the quality product when integrated with the build. Okay, so these are the advantages of unit testing. So that's it for today's session. We will stop here. Thank you.